Hey guys, good morning. Um, yeah, well, things are winding down towards the end of class and towards the end of the quarter. And some of you, at UCs are probably in your final week of exams. So hopefully next week onwards, you'll be able to do 100% of your time on this class, as is required, I think. So I'm pleased to see the awesome progress some of you are having in the Reddit. So that's fantastic. It's great. So yeah, so today, like I said, we're just going to play around with sorting techniques. And what we'll do is start off with very, very basic, uh, you know, uh, very basic sort. And then we'll try and look at it from a computer science perspective, really. So to say, well, what is the total amount of work we're doing in sorting these items? How many times are we comparing things with each other? Can we do better than that? So, and I don't think we need to come to any conclusions about that in CS2A. Not even in CS2B, like I said, your sorting algorithm comparisons, well, there's a little bit in CS2B, but getting a firm intuition of sorting, we'll have to wait until CS2C, but certainly we can start it off in this class, not just by blindly implementing a sorting algorithm, which I did, when I was learning computer science very early on. I was just blindly implementing many algorithms, just getting them to work. And yeah, okay, it works. I've got the answer. And I had no idea, never really appreciated anything, right? And it's only later when you actually ponder these algorithms that you actually find out what computer science is, right? As opposed to just doing something to, get past a milestone. So yeah, so we'll start doing that today when we do sorting. I have a couple of ideas in mind. And we'll try playing with that, okay? Hey, Bao, wait, well, welcome to class. You are you an online student or a face-to-face student? Can hear you, can hear you.
Can you hear me now?
Yeah, I can hear you.
Yeah, I honestly don't know. Sorry about that.
Online?
I have no idea. Sorry.
All right. So you have to find out because either way you're not getting any points for participation. You know that, right? For nine of 11 weeks that you're not getting any participation points, right? And it's a big hit to your GPA. I don't know if you understand that or you don't care about your GPA and all, and you're just here to pick up the skills. That's fine. But I just want you to know, okay, just so you're not in for a rude surprise at the end of the quarter. 9 of 11 weeks gone without participation is a significant hit, isn't it, for those 15 participation points?
Yeah.
So, all right. So, and likewise, you should also pass the message on to all the other students who have not been attending class regularly and not being active on the forums. And also not showing any evidence that they're struggling with these problems, rather than waiting for someone else to solve and looking at their solutions and solving them, or looking at their tip sheets. That's not the way to master computer science. You have to try everything yourself, otherwise there's no point in doing computer science or CS2A other than pick up a piece of paper, even though that won't help you. Nobody cares about these qualifications on paper. I can tell you right now, okay? I've hired lots of people. I've interviewed lots of people. I've seen many of my friends interview them, on an ongoing basis every day even. And I can tell you, nobody cares about your transcript. Your transcript may sometimes get you a foot in the door for an interview, but beyond that, nobody cares. So it doesn't matter if you went to the best college in the world, or you are self-taught as a programmer. The only thing that the best college in the world can get you is get you an interview saying, well, you know what, this person tried a lot to master some really hard stuff here. Otherwise, he couldn't have gotten to this college. So please give that person an interview so he or she can do well, and then you'll find out that you can hire them. Okay, so that's the only advantage that going to a top school gets you. what is, but people who don't go to top schools, self-taught programmers, and even people who go to lower tier schools don't have the advantage of getting a freebie interview. However, they have an equal chance of getting an interview, by the way, right? So anyone who even is a self-taught programmer who's done the right thing or gone to a not so reputable school has an equal chance as someone who goes to a top school and gets an A plus degree at a top school to get an interview at one of the top software companies if they manage to put what they learned to, that is, I'm talking about self-taught programmers, right? They manage to put what they learned to use and produce something that they're proud of, that they can showcase out there. That is, that's a much better chance of getting an interview than going to a top college and having nothing to show, right? I know people who have gone to top colleges, okay, top schools who are not getting interview calls, okay, not getting interview calls despite applying to many places. And I had a chat with them, one of them 2 weeks ago, I think. Right. And I said, despite doing all these cool things, and I'm not even getting interview calls. And that's because it's been 2 years since they've graduated and they have nothing to show. Right. And so who knows if they were just a one-off, one-hit wonder. So you don't know. Right. So even if you go to a top college, doesn't matter as if people don't have something to show. And so it's very important that people attend class and participate eagerly and enthusiastically. Otherwise, they're not going to get anything out of this class.
And so I told you that because of my personal situations, I missed a couple class. I fell behind, so I went online. I tried studying the book, but I just couldn't get anywhere. So I just self-study basically. And I'm trying to catch up by myself.
Yeah, totally. Yeah, that's very good, right? It certainly is possible to catch up, not all the way to A anyway, right? But certainly it's possible to catch up and pass the course and even get a better grade than a C by doing things well from now on. At the end of the day, by the way, I can assure you, your grade is not going to matter. Okay, it is only what you learn. What you learn that's what's going to matter, because that is what is going to dictate what you're going to build later on in life. So that's what's important. And also right now, and thankfully this is being recorded and other people will watch it too. Right now is a time when I get a lot of email from students asking for one-on-one Zoom sessions to talk about particular questing issues or difficulties, debugging code, and so on and so forth. I want you to be and pass this message on, okay? No, absolutely no personal quest help, all right? Even if you do have a one-on-one with me, if you ask a quest-related question, that is not allowed, okay? That is well, not allowed in the sense you'll take a serious hit in your participation score. If you ask me a quest-related question in a personal one-on-one on a Zoom or something, you can ask quest-related questions in the forums, where everybody's listening and lots of people can answer questions. So that's perfectly acceptable. And also STEM Center, I've told the tutors, I don't know how much they're enforcing it, but no one-on-one quest related help, okay? They can help you with concepts. So for example, even with me, right? If you have a one-on-one to clarify a particular concept, you can say, I'm trying to do this, right? I'm trying to take a bunch of linked notes in a list and I'm trying to remove a node, right? And how would I do that? And so different ways, right? So then we can have a one-on-one in which I can walk you through one of those problems and say, okay, implement this now. Let's create a list. Now you want to remove that node, okay? So go ahead and do it, and I can walk you through it like in class and give you a much better idea. But certainly no quest code. The quest is essentially, I think in machine learning, we have this idea of a training set and a test set. I don't know if you guys are probably not aware of it, unless because some of you are already in the field and probably are doing this in other languages, but I don't see many of you here today. But the whole idea of training set and test set is that when you have a neural net or a machine learning system with weights in there that are not yet tuned for a particular domain or a task, it's not, you can't use it for anything, right? It just does random stuff. But you need to train it so that it behaves in a particular way in a particular context. So you take a brand new neural net, or let's say brand new black box of a machine learning system, and you're going to keep feeding it lots and lots of data for which you expect a certain kind of output. So you feed it the data, and if it gives you the wrong output or undesirable output, you'll say, no, that's not the way to do it. I'm going to hit you on the head and change all your weights a little bit. So the next time you get a similar looking data piece, you'll tend to err, or tend to behave in that direction. So over millions and millions of little data points, you look at the observation system behavior, and initially it's going to be 50-50, because it's going to say, is this good or bad? And it'll say, good or bad. It'll say, this is good, good is bad, yeah, this is bad. 50-50 likelihood, no information there, right? But eventually we say, you said this is bad, no, this is actually good, go and change your weights. Okay, relearn, right? Re-examine your assumptions. Right? That's what we tell the machine learning system every time you give it a negative example, and it example, and it produces a wrong result. You're going to say, no, that was wrong, re-examine your assumptions. Okay, look at the world with a brand new pair of eyes. That's what you're telling them. So after millions and millions of such data points, the system will basically turn to look at the data and give you, on average, a better than average correct predictions, saying this is good and that's bad. Okay, 80% of the time it's what it says is good, and what it says is bad, right? 20% of the time it'll be wrong. And how do you minimize that? So one of the ways in which people try to tune machine learning systems is to not, if you have a whole bunch of data, saying, oh, all of these are labeled examples, meaning I have this much data in which every single case I know whether it's good or bad. Okay, so I can use this to train the system. So I can take that, if I give it all to the machine learning system, it can look at it and say, well, all of that is good and all of this is bad. I can learn and tweak my weights accordingly, right? However, if you did that and then a brand new example came along and you didn't know if it was good or bad, and you gave it to the system, and you have no idea whether it was 80% right or 20% wrong, you don't know what it predicted. Yes? So what people tend to do is that even though you have a large data set that is already labeled, it's called an annotated data set, right? It's a labeled data set where you already know what the output should be, right? Because in the real world, you don't know what the output should be, right? But in a trained, the tagged data set, you know what the output should be. Now, the clever thing to do is to not take the whole thing and give it to the machine learning system and go learn. Okay, the clever thing to do is to say, even though I have like 100,000 examples, for each of which I know whether it should be good or bad, I'm going to take 80% of those, 20% of those, and not even show it to the machine learning system, right? I'm going to hide them away, and I'm going to give the 80% to the machine learning system and say, now, look at the 80%, 80,000 examples, which each tell you whether it's good or bad, and tweak your weights accordingly. Okay, and then with the 80%, the machine learning system will, train itself. Now you want to know how well it's trained itself. Now you can't use a real world example to test it, but you use the other 20% that you've tagged, which whether it's true or false, right? You know whether it's true or false. Now that you can feed the system without giving it the output and check its output and say, well, you know what, this 20%, 20,000 examples, I know whether it's good or bad. I'll give it to the system and find out how many of it is, how many of these were actually correct. So that way you can measure it, yes or no. Okay, so now that division is called the training set and the tuning set. Some people will say there's a held out set also, right? Because it's held out from training. It's not, given to the system, it's held out. So that is the same way you should approach learning in classes also, right? So in classes, you get a whole lot of exercises to work on in class and, with your friends and so on. But when it comes to the homework assignments, okay, those are not meant to be worked on together, okay, because those, and the exams too. So the exam, you can say it's a final test, but the homework assignments, like the quests, are meant to be worked on your own. If you go to a STEM center or your parents or friends or brothers and sisters and say, help me with this, and they help you solve the problem, okay, that means you're contaminating your training set. Do you know what I mean? Your training set is contaminated, meaning that now from that point onwards, you don't have a true measurement, true calibration of your own brilliance in solving that problem. Okay, from that point onwards, your A plus that you get in that class will not matter. Okay, because that A plus does not really mean that you are an A plus person in that field. It just means that you somehow managed to wrangle an A plus by doing some illegal stuff. Okay, but doesn't mean you really know the stuff. So in order to prevent that, all teaching institutions provide you with 2 sets of data, 3 sets of data. One set is stuff that is worked on with the professor, with the instructors, with the tutors in college, right? With other people. You are meant to do it in a group. The other set is for you to do it on your own without other people's help. And you'll have the numbers at the end, but to check whether you got it right. That is the held out set. Yes. The final test is your test set. This is 3 divisions is exactly what you'll encounter. If you are ever planning to major in data engineering, machine learning, AI, and things like that, these are the 3 divisions you'll encounter, right? The training set is meant to train the system. The held out tuning set is meant to be given to the system to measure its own quality. Okay, now if the machine learning system does some stupid thing, right? It's basically a stupid thing saying, well, I got a held out set, but I need more training. So I'm going to take the held out set and throw it into the training set. So I got more training data. Okay, if it does that, it is the stupidest thing that could do, because from that point onwards, it won't have any way to measure its own quality. It won't have, because the next thing it's going to see is a final exam or the real world. And the real world example could be true or false, and you cannot tell, right? Yeah, Bauer, yes, go ahead.
I agree with all of you have said that contaminating your work with like other help and stuff is non-excusable. But what about asking for help to understand it? Maybe
Understand the concept is perfectly fine. Okay. Yes.
Yeah.
Yeah. Totally. Yes. Absolutely. Thank you for asking that question, Bauer. Okay. You should totally feel free. In fact, I encourage people to do that, and I don't see that in the forums. Okay. I don't see that in the forums, and so I don't know if people are actually asking for concept help or just looking it up and asking people for actual answers. If people don't ask for concept help and just come up with miraculous solutions to questions, then I can only assume that they basically copied it or got it from someone to do, got a brother or sister to solve it for them, right? Because I don't have any other evidence. And also at the end of the day, I can't enforce these things, right? That's why I'm saying it is in your interest. It is in your interest to look at the 3 kinds of data as separate, okay? The assignments and the homework, not in my class, any class you go to. Right? Assignments and homework, they are your held out data set. You are meant to work on them on your own, unless it has been clearly marked as a group assignment that 5 or 6 people should work together. Homework problems, math proofs, okay? They're meant to be worked on your own in order for you to gauge your own level of understanding. If you work under other people, you'll never find out your own level of understanding. And you lost this brilliant opportunity, right? Great opportunity to and then you'll just have a rude awakening in the final exam or in the real world, which we want to minimize the chances of that happening. Okay, when you go out there, we want you to be awesome people, right? Awesome people, confident, never panicking, always cool, and know the solutions, and say, well, this is easy, man, let's go and do it, right? Let's go and take a look at it and solve it. So you should have that frame of mind, right? Always be able to be unfazed by these problems. And this is what working on the assignments on your own will help you, because at some point, someday, you are going to be working on code on your own. No matter, even if you're working in a big team with lots and lots of people, there's going to be many situations where you got a bunch of code and you got to work on it on your own. If you've never actually gotten comfortable with the idea of working on code on your own, you'll find it's really hard later on. So please take this opportunity. Okay. So thank you all very much for listening to that. And thank you for attending class. And also relating to question number 9, if you're stuck with stuff to do with pointers and linked list and question number 9, wait until next week, because we haven't really covered it in class. And obviously you're welcome to talk about it in Reddit, right? Because some people would have progressed ahead. Obviously, I know some of you have already progressed ahead to quest 9, and they can help you. But I would say don't panic and just wait and don't rush to get help on Quest 9 issues and pointers and linked list, because especially if it's the first time you're encountering pointers, I think that at least a couple of weeks of banging your head on your wall, right? A couple of weeks of frustration is necessary when you're first dealing with pointers, right? And I can guarantee that those 2 weeks will never ever be faced by you again in your life, right? You're gonna 2 weeks of desperation with pointers. You can either face it now or later on when you're working at a company, right? And I think it's better to face it now because it's just one time, right? It's a one-time pain. It's better, and you have to face it. You have to face it, and also don't skip it, right? Don't ask for solutions and say, "How do I get around this?" But think about this and step through it on a piece of paper, right? Walk, well, draw it, and understand it, and it will all greatly help you, right? Don't skip it or take the easy way out by yeah. Concept help is fine, and you should feel free to ask. Thank you. Thank you. Right. So yeah, today this is what I'm planning to do is basically work on a linked list. And hey, Bao, no, not linked list, sorting. Linked list is next week, right? In fact, linked nodes next week. We'll do linked nodes and do a stack based on linked nodes next week. Okay, and the week after that, which is the last week, right? Next week is week 10, and the week after that is the last week of classes, right? Only 2 more weeks. Is that right? Only 2 more weeks, because week 12, technically, we're not allowed to give you classes. Is that right? There's only 2 more weeks of classes, week 11. Is this week 9 or week 8? This is week 9, is it? Wow.
Week 9.
Okay. Yeah. So there's only 2 more weeks of classes. I don't think, well, we can have a class in week 12. I don't mind, especially if a bunch of you want to have a class and have to, want to have a practice run with some code. All of that is fine. But technically, I don't think we're allowed to introduce new material in week 12. So there's only 2 more weeks. So next week we'll talk about pointers and structures, classes that contain pointers. And the week after that, we'll talk about how you can use pointers to create a linked list. Right. Next week we'll also do a linked list, but we'll do a stack based on a linked list. Okay. Because in your questing, you implement a stack, but it's not a stack based on linked list, right? In your quest, you implement a stack based on an array, which is easier. Well, actually, no, I shouldn't say it's easier. And maybe it's harder, right? Stack based on a linked list is actually easier. It's probably well, no, I think it's possible to do both in the same number of lines of code, even, right? 20 to 20 lines of code, 20 to 30 lines of code. That's all you need to implement a stack based on a linked list. And it's it's more code than you wrote for your stickman animation. You've written 150 lines of code for stickman and animations of things like that. So yeah, you'll be surprised that you can do these things. And increasingly, you'll find that as you advance in computer science in general, you'll start writing less and less code, but you have to think more and more to write less and less code. Okay, yeah, so it's interesting, isn't it? Initially, you just write a lot of code, but as you get better and better, you start writing less code. But in order to write less code, you have to think more and more to figure out what to do exactly. So it'll be fun. I can guarantee it'll be hugely fun if you stick with it. Stick with it, persevere. And I said this in the syllabus, and I don't know if people actually read the syllabus or not. But it is very important to feel the feeling of frustration and to feel that you are not cut out to be a programmer. Now, maybe some of you are already programmers, okay? So maybe you felt the feeling and you've gotten over it and all. But everybody I know who is a half-decent programmer has felt this in the past, okay? You have to go through an extended period of time, maybe even a couple of weeks, when you feel in your heart of hearts that, well, I'm not cut out to be a programmer. Okay, you're going to go to sleep like that. You're going to go to sleep thinking, well, there's all these people making a killing out there, creating these cool products, and I'm not cut out to be one of them, right? Maybe I'm cut out to be something else. physicist, biologist, artisan, whatever it is, not programming, right? I'm not going near programming. So, and that is a feeling that you have to feel. And the reason I say you have to feel it is because this is the only chance you'll get to feel that feeling. When you start feeling, if you feel, take this and pass this message on to everybody else, okay? Maybe not even your classmates, anyone else out there in the world that you encounter, okay, who is trying to be a programmer, but not, right? And the reason you have to feel this feeling now as a student is that this is the only time you will have the perseverance, tenacity, and also the possibility of sticking it out and overcoming it, okay? Because right now, it's sunk cost. You got to finish this class anyway, right? You've enrolled, you've got to finish it, okay? So if you have to stick through a couple of weeks of hopelessness, thinking I'm just going to do it because I'm not going to be a programmer anyway, I'm going to do it, okay? And you still do it, that is the only thing that will force you through those 2 weeks, because at the end of the 2 weeks, if you reflect and you say, wow, I felt like that 2 weeks ago. I can't think of anything else I can do in my life other than programming, right? It looks like programming is cut out for me and I'm made for programming, right? So this is like an ideal marriage here between me and programming. And I was thinking that's not for me, right? And why is that? Because it's like everything else in life, you have to watch it rise up. And if you're working, if you're out there, if you're not a student, when you've reached that point, when you say that, this is not for me, if you're working, you have all the freedom, all the temptation, and it's an instant switch very quickly. It's very tempting, and you'll switch. You'll say, well, this is not for me, and people will leave, right? I've seen lots and lots of promising programmers who basically just give up at that point because they were able to give up. Now you're not able to give up because you're locked into this course, and you have the best chance of riding the wave, because everything that crescendos, and you say, well, programming is definitely not for me, I'm going to give it up tomorrow, okay? You sleep over it, the next day you will feel differently, okay? You got to watch that up and down, right? And I'm pretty sure you've felt that many times in life, in many other situations, right? In fact, I've mentioned this to students. In fact, there's even a meditation technique that they teach in India, where you are taught to observe sensations that occur on your body, most likely under your nose, because your breath is going to tickle your lip, so you'll have sensations appear on your lips if you don't do anything at all, just by breathing, because the air hitting the lip, and you start feeling an itchy sensation. Or you want to do that, okay? And it's tempting to do that, and most people just do that unthinkingly, and the instruction says, don't do it, right? You're not going to die because of that itch. Just feel it and see what happens. Complete the trajectory, essentially complete the trajectory of what started out, right? Don't stop it when it's here, because it's not going to kill you. Just watch what happens, and then you'll see that after a while it goes away, and 5 minutes later, and you reflect and think, wow, you know what, I had an itchy sensation here and I wanted to scratch it so badly, but I just stuck it out and said I'm not going to do it, and now it's gone completely. I know I don't even want to do it, right? Now that is a feeling. It is just an example of one simple thing that you should extrapolate from that point onwards, right? They don't say this is what you should do everywhere, but it is a feeling that you should latch onto and say, wow, everything in life is just like that, right? Including learning, right? Even hardships, horrendous things happening in life. Most of the time, time is the best healer, right? So if you just stick it out, you can see that ebb and flow, right? And it'll disappear. And this feeling is very important, that you have to feel that this is so frustrating. I'm never ever going to get to the bottom of this, okay? I have to switch fields, feel it, and get to the bottom, and you'll emerge on the other side and say, well, I'm glad I didn't give up. Okay, so that is really where you want to be, because once you get to the other side, then it'll be easy for a long time. And, every time you come to a learning curve, again, you'll feel that too, right? So learning, in my experience, is like this, okay? It has many of these ups and downs. Now, the thing is, if the first time someone went to an up and then there was a down, and they felt that, oh my gosh, I got to give up, they're never going to get up here, right? Because they would have given up already. But once you've gone up and come down once, then you're familiar with the feeling of having been frustrated in the field and overcoming the frustration, which means that the second time you feel the frustration, which will be even harder, right? It's going to be even harder now, because the second level challenges will be harder. you will not be phased, because I felt that already and I overcame that. So this is not a big deal. I defeated the little bosses. Now these are mini bosses. Now I got a big boss. It's not much different. It's just the same strategies. I just have to wait it out, be patient, perseverance, and I'll get there. So, and it is also training. Okay. So learning in a college is not just picking up knowledge. It is also picking up meta knowledge. Okay. Meta knowledge is how can I pick up knowledge in a more efficient way? All right. Knowledge is what you get. And meta knowledge is how can I pick up the knowledge in the most efficient way? And these are the skills and techniques that you'll pick up in the meta knowledge part of your learning in college, is to say, well, all the techniques. I've experimented with thousands of techniques like this, right? When I was your age in college, I was so, I was like 1 million things to do and I didn't know which to do first. I created lists and I tried prioritizing lists, all these, and those days, no phones and computers, right? I had to do these paper lists. And I, all these kinds of crazy things, right? Very few of these things worked for me. Okay. And everybody will have to find their own beat. And you have to try all these different techniques, and one of them will work. But the most important thing and common thing to all of the techniques is just perseverance. Okay. Not giving up in the face of obvious failure. Okay. Nothing is obvious. Even failure is not obvious. It'll look obvious, but it looks obvious because you overlook something. Maybe there's something here that you didn't see that is going to give you success. It's right behind you, but you couldn't see it. And you say, I'm going to fail. But no, you just keep going. Even though you think you're going to fail, that thing that is going to give you success will catch up with you and go ahead and make you succeed. And so how many people have just given, Tim posted this incredible comic, right? I like that very much. So yeah, so you just keep going. You don't know what is going to give you success. Maybe this is the last, chisel on the wall, right? And breaks it open and all the diamonds, pouring out of the cave, right? So, so that is very important. But if you don't have perseverance, you may not make that last mile. And so that's why it's also important. All right. Okay. So I would like to start, picking up the code and not picking up the code. We don't have any code, right? Today, with sorting, we're going to do a very, very basic sorting technique. And again, you are going to be doing most of the coding. I'll be on the sidelines watching and helping you also where necessary. The first thing we're going to code is basically a very, very simple version of a sort. Okay, so here's what you're going to do, and I will not. So whoever is going to pick up the screen, here's the deal. Okay, and we'll try if it works. If it doesn't work, I'll come back and talk you through the code. But I want to try this because we only got 2 more weeks. Okay, I want to do this. I would like it very much, very, very much, if one of you would play my part today in speaking, in talking one of your classmates through the code that we're going to code today. Okay. And it's going to be very simple. And here's what you're going to do. And it doesn't have to be one person talking. Okay. It could be 2 or 3 people talking the code and one person typing. Okay. And here's what we're going to do. We want a main and nod or tell me or give me some feedback if you understand it. Here's what we're going to do. So today we're going to in your main, you're going to create an array of, let's say, 100 items. Okay, 100 numbers, 100 random numbers. Use rand. Everybody know how to use rand? Yeah. Okay. You're going to use rand in a tight for loop. You're going to fill a vector with 100 integers. Okay. Now, what you're going to do, you can do all of this in main. You don't need a separate function right now. Okay. We can split it out into a separate function, modularizing it later on. Okay. And then after you filled out the vector with random numbers, you're going to go into a second section, which is also going to be a for loop, but a nested for loop. Okay. And all this is going to do is it's going to scan the vector from top to bottom until it finds the minimum element. Okay, is that possible? That's easy, isn't it? You assume the first one is a minimum, compare it to the second. If it's not the minimum, well, the second is a minimum, right? So you keep changing your hypothesis as you examine each element, right? You make your hypothesis saying the first one is a minimum, right? If it's not the minimum, you change your hypothesis, make the second one the minimum, and then examine the third. So you keep on changing. So by the time you examine all of the elements, you are certain to know which element is the minimum element. Yes or no? Okay, once you've identified the minimum element, all you have to do is swap the minimum element with the first element. Bam, like that. Okay. After that, you're going to do exactly the same thing, except it's not the whole array. We know that the minimum element has already gone to the first element. Now you're going to do the same thing starting from element number 2 to the end. Find the minimum from 2 to the end, and then swap that into second position. And then find the minimum from the third to the end. Swap that to the third element. Now, that's all you're going to do until you get to the very last element. Okay? And when you've got to the very last element, your entire array is now completely sorted. Now, to confirm that, what you can do is before you start your sorting dance, okay, you're going to have, you have the for loop that fills the vector with randoms. Have another for loop which will just print out all the values, right? See out vec1, vec2, vec3, and all, right? So up to vec100. So you're going to maybe just do 10 elements for testing, maybe, right? So you're going to say 10 elements, right? So vec2 to vec0 to vec9. You're going to fill it with randoms. Vec0 to vec9. You're going to print it out with cout. Now you're going to sort using this technique that we talked about. And after sorting, you're going to print out vec0 to vec9 cout. Okay, so you're going to have these blocks. So all together, we're looking at, I don't know, 20 to 30 lines of code, probably not more than that. And so what I would like is for one of you to volunteer to code. Hopefully, Bao, if you're able to, you can code. If you've watched the previous videos, you'll see that it's not difficult at all, because even if you don't know anything at all, most of the time what happens is you just have to keep typing what other people tell you. Yeah, hash, include, open brace, curly brace, parentheses, and so on. And if you make a mistake, people say, no, backspace and curly brace and so on. So low stress, nothing. It's just coding like amongst friends. But what will happen is that as you're coding, 50% of the way, you'll start feeling more comfortable with coding yourself, right? And you'll start doing things, and it's actually a huge practice for everything you'll be doing in programming, in questing and everything. So Bao, if you would like to do that, I'm pretty sure we have a lot of students in class who will be able to, help you out by describing the steps in very great detail, say up to the level of what you need to type. Are you willing to do that? Or are you at a computer where you can share your screen? Bao? Are you at a computer where you can share your screen?
Yeah.
Are you willing to code today when someone else talks you through the code?
I mean, I'm kind of behind, but yeah, I guess.
Yeah, don't worry. All right, it doesn't matter. You're behind. We're going to try and catch up on all. So this will actually be very good practice for you. And so the important thing is, don't feel self-conscious. Okay, when you're typing, you should just turn yourself into a robot, meaning you don't have any feelings from that point onwards. Okay, even if someone calls you a fool or an idiot, yeah, it's fine. You can call a robot a fool. It's not going to say anything, right? It's not going to hit you or anything. So just turn into a robot, and all you're going to do is turn into a typing robot. So if someone says A, B, C, you're going to type A, B, C, that's all. Okay. Now, you will find that it is a magical experience, because you start out being a robot, but somewhere along the way, some of the instructions that are passing through you to the robot will basically make its way into your brain too, right? And you start saying, oh, well, that's why the robot is doing this. That's why the robot is doing this, right? And by the end of the class, you'll actually be typing ahead yourself too, without your knowledge. Okay, so it's actually a very great feeling. You can talk to all your classmates. Every single one of your classmates here has coded. Okay, Michael, Kate, Hasanta, Jaden, Tim, Chongwen, Kiki, everyone, all of you have coded in class, right? And was it a good experience? Yeah, well, some of them are hesitant, but I'm pretty sure it was a good experience for most people. And if not, you should, let Bao know. And so Bao, yes, please. So when you're ready, because you haven't shared the screen before, what you should do is, before you share, open up Chrome. Is it a Mac or a PC?
It's Windows.
Windows, okay. So what you have to do is open up Chrome or Edge or one of those browsers, and then open up an incognito or private browsing window. Okay, don't open up a regular window. Open a private window. Do you know how to do a private window in Chrome?
Yeah.
Okay, now that is the window you should share in Zoom, right? In Zoom, when you go to share screen, share the private window.
have it up.
Yeah, okay, now share it. Share it with great. Okay, excellent. Thank you. Now go to onlinegdb.com. We'll do it in online GDB. Is that okay with you guys? Now, I'm not going to be coding. Okay, I'm not even going to be speaking out the code, and I'm looking at you guys, and because every one of you here has coded before. Okay, and you should let me know if I'm mistaken, and I should come back and talking. No, GDB, not P. Onlinegdb.com. GNU debugger, right? Online GDB. Online GDP. I wonder what that is. Okay, now yeah,
something from there.
yeah, gross domestic product online. Okay, Control A and hit delete. Control A, delete. Okay, now on the right side where you say language, select C++. We have the language
Where
tab.
does it say that? Oh,
Yeah,
right
there
here.
you go. That's all. Okay, now from this point onwards, I hope Tim or Kate or Jaden or Hasanta, Michael, Kiki, Chongwan, they're going to take over. Okay, maybe one of you can basically say I'll take over, and everybody else can also chime in, because it says, you know, if everybody is, I'd like one of you to coordinate the, you know, talking through rather than just leaving it open, because if it's open, everybody will think that someone else is going to speak. Okay, so I'd like someone to volunteer to say I will be the coordinating talker througher. Okay, and this is what we're going to do. Someone who understands what we need to do today should be the coordinator, and then everybody else should be able to talk through. Well, maybe the coordinator could talk through, and the other people can also, you know, chime in saying, well, you know, all these things. Okay, so who would like to do that? Who would like to walk Bao through this code today, which is going to take create a vector of 10 elements, fill the vector with 10 random numbers, print out the 10 random numbers, then do the sorting like I described, okay? And then print it out again. So the idea is that first it's not sorted, finally it should be sorted. When you have that working, we can start talking about the nuances of sorting, okay? Let's say, well, how can we make it better? This is your basic sort method, because this is how you'd sort, right? If you go to kindergarten and ask the kids, you give them a bunch of blocks and say arrange them in increasing size, this is what they're going to do. They'll find the smallest one and put it on the left. Next smallest one, next, right? This is what they're going to do, right? That's how children sort things, I think, right? They're not going to do quick sort, like pivoting and all, you know? So this is your absolute simple, intuitive, you know, straightforward sorting method. So we need to get solid on that and know how it works and confirm to ourselves that it works before we start thinking about the more advanced sorting techniques. So that's why this is like super duper important to implement. And, you know, even if it takes a whole class to get this done, the whole class, not meaning the whole, all of you guys, I mean the whole 2 hours to get this done, it is going to be worth it, because that is your solid foundation in coding, right? In sorting techniques. Okay, so who'd like to coordinate the coding with Bao today, right? Who's going to talk Bao through this while you know, having everybody else also behind your back? Everybody else is going to talk through it, but one person needs to coordinate. Can someone volunteer to do that?
I can help up to the creating the vector for 10 numbers.
Okay, Hasanta will take care of the part where you create the vector. Who can take care of the part where you fill the vector with randoms? Hasanta said he'll take care of the part where, you know, starting from main, hash include and everything, and declaring the vector, and creating the vector. One more person needs to say, now I'll take care of creating the for loop, which will stuff the vector with random numbers. Who can do that?
Oh,
Kate, thank you. Right, right. So we have Hasanta and Kate, and then one more person now needs to. Kate, you have to come in 2 times, okay? Because oh no, you're stuffing the vector with randoms. Another person needs to take the vector that's been stuffed with randoms and print it out on screen, saying "see out, see out, see out." Right. So someone else needs to do the for loop to print out the 10 random vectors. Who can talk about through that? Okay, so we have Hasanta and Kate for the first 2 parts. right? Who can do the printing out of the vector with cout? Nobody wants to do it. Nobody wants to loop through the vector and do a cout statement, printing the values out. This is week 9. Are you guys not comfortable with looping through a vector to print values out? So how can you do the final then? How can you do the final exam if you're not comfortable with looping through a vector and printing out the values? Okay, someone should do this.
We can help. I can
Okay,
help.
Asanta, you're coming back now. All right, so Asanta will do. So in between, Kate will take over to print, fill it with randoms, and you're going to print out, right? Asanta, you'll come back and print out the vector with randoms.
Yeah. Okay.
Okay. So someone now should take over the part where you're going to find the minimum and swap it with the top. Find the minimum, swap it with the top. Now, if you're stuck at this part, someone should do it, right? Not me. Someone should do it. But if you're stuck doing this, you can call me and I will sit down and walk you through this, okay? And pull you out of ditches that you get stuck in. I will be happy to do that because this is slightly, it's not complicated. It is, not trivial. So this part, again, one of you should do. And I'm looking at who else hasn't volunteered now. Tim and Michael and Kiki and Chongwen, one of you, or Jaden, one of you should basically do this. Okay, you should say, I'll take care of the part where you're going to have nested for loops, and you're going to say, I'm going to find the minimum, yank it to the top, and then find the minimum, yank it to the top, and so on and so forth. Right? That's what you're going to do. Now there may be bugs in this part, and I will help you fix those bugs. I think very likely I'm going to have to come and help you guys. So don't worry if you don't get it right. But this is another part that you need. I need a volunteer to drive. Okay, so who would like to do that?
Yeah, sorry. If
Jaden, you'd like to do that?
No, just if I'm having trouble volunteering, I guess I'm not really good at explaining like this kind of stuff to how to form it. And
okay, don't worry. So how about someone else? Okay, not Jaden. Jaden, excuse yourself.
Yeah, I can do
How
it.
about Michael? Thank you, Michael. Hey, your camera's off, by the way. Yeah. So yeah, Michael, thank you. Right. So Michael will take over the part where you're going to do the loop, and then find the minimum, yank it. Find the minimum, swap. Right. So he's going to do that, and then finally, after the sort is done, we need Hasanta to come back. Hasanta, where were you? You were the one who said you'll print out the values in the vector, right?
Yeah.
Okay. So you'll be doing it 2 times, once before the sort and once after the sort too. Yeah.
Yes.
All right. So do we have a plan? Hey, Jaden, you have your hand raised or are you scratching your head?
scratch my head, but
Okay. All right. Cool.
actually,
Any other
I do
questions?
actually. Sorry, yeah, I do actually have one question for about if that's okay.
Sure, no worries. Yeah, it is okay.
And
right?
I don't, no, I don't want to be rude in saying this, but so what have you picked up so far, so we can get an understanding of what we kind of need to explain?
I'm sorry. Yeah. Hey, Jaden, I couldn't even. Can you say that again? Sorry.
I was asking him what he has learned so far, what he's picked up so far, so we can have an idea of what we need to explain.
No. Don't. Right. Let's assume that he has not picked up anything. Okay, because he may know already. But in the capacity of a robot typist, which is what every one of you has initially volunteered for, right? We should not expect any prior knowledge from him, right? We're just going to speak our understanding of programming by saying, hash, incl, include, angle bracket, every single thing, character by character. We're going to, the person who's talking will say, and he'll type, and you can correct these. But in the process of doing that, he'll automatically figure out the places that he needs to get strong in, if necessary. Yeah. So don't anyone don't need to ask. What you already know.
I thought that would help.
Yeah. That way, it'll put everybody at ease. Okay. because then there's no expectation that you need to know anything before typing. You can just come and type and just have a good time at it, and then everybody will have a good time too. Okay, is everybody okay with this? You guys want to start? Yeah, you want to start? Exciting. It's exciting, isn't it? Okay. All right. So I'm now going to hand over to, who was the first one? Hasanta or Kate? I keep forgetting. Hasanta, you were the first one.
Yeah.
Because you're going to set up with the template code and hash include and creating the vector. Yes?
Yeah.
And then after you've created the vector, basically declared the vector, right? After you declare the vector, hand over to Kate, and Kate will do the for loop where you stuff each of the vector items with a random number and then give it back to you. No, after that, she'll give it back to Michael, right? And Michael will take that vector and sort it. Oh, no, actually, after that, she's going to give it back to you, and you're going to print it all out. And after you print it all out, you're going to give it to Michael, and Michael will sort it and then give it back to you, and then you'll print it again, right? All of that is going to happen in the same file, right? It's just, who's going to talk while Bao is typing. Everybody okay?
Yeah.
All right, great. All right, let's start. Bao, you ready now? Take a deep breath, okay? And prepare to dive. Okay, now Hasanta will start calling out what you need to type, and just keep typing, and eventually it'll just click, okay? And call me anytime, right? If you're stuck and it's a prolonged silence, that is no good at all, okay? You should always be talking, even if it's wrong, don't worry, okay? Nobody cares about these things. So keep talking and helping each other, asking questions, and if you're stuck, just call my name and I'll be right back, okay? I'm going to be here. I'm just going to be listening, so I'm not in your face. Because if I'm looking at you, you guys are not even talking, okay? If I'm looking at your face, I don't know, is it because you're self-conscious, or I don't know, right? I'm trying my best to make you not self-conscious, because I'm just one of you. Essentially, I'm just one of you. I just have a little bit more experience in coding, that's all, okay? But I'm one of you. You should treat me as one of you, because I'm trying to get some stuff done. You're trying to get some stuff done too. All right, we're all in this together. So, but yet, students always feel uneasy when the professor is around. That is, I don't know, that's crazy, okay? So I'm not going to be in your face. And that's the only reason why I'm turning this around. Otherwise, I'd just be sitting here and looking at you guys, okay? So I'm going to be back there listening to you, right? Please do talk and get this going, okay? Hopefully you should get this done within an hour, okay? Max of an hour, you'll have this done. And then we can have a discussion about this too before the end of class, okay? Is that okay? All right. Okay. All right. Take it away. And I'd like to hear some interesting and incredibly beautiful voices now.
Hi, Bao. You can start with including the IO string, vector, random. And I include string.
Include stream.
Yes.
So IO and stream.
I believe we need strings. Then we're gonna need the vector also.
Include vector.
Yeah. And random. Include random. So then using namespace std main. Std semicolon. Int main. Yeah, so we can declare the vector, int vector. It's called vector. No, it's vector, then the caret sign, the less than sign, int, greater than sign. Then the name of the vector, whatever you like.
What should we call it?
Like a vector list or something, or array list.
Vector what?
List. Yeah. Then I think we can declare the random number also right here. So,
Like, how did you do that?
so it's going to be an int. No, like the next line. So int. So it's going to be a variable called random number, random or something. Equal to rand open and close brackets. So the professor said it should be 10 integers. So what I learned, when you normally need 10, you can get the remainder from 11.
So what do I put here?
You put rand,
Yeah.
open and close bracket, then the percentage
this?
sign.
Or what do I put after the
It's rand, then the open and close bracket. You're basically calling the
bracket?
random function in a way, random. The small brackets, the other one.
This one.
Yeah. Then the percentage sign
Pressing.
outside. Percentage sign.
What sign?
Percentage shift 5.
Oh, percentage.
Yeah.
My bad.
So we need, I think, 10 numbers. So I think you can divide it by 11. So you always get the remainder as less than 11. So you can put 11 after the sign. Yeah. Then the semicolon. I don't know, is that the right way? I think to fill out the array list, you can start a for loop, and I think Kate can help with that. I think that's about it, right? For the vector.
Yeah. I don't know if you need a random number because we know it's going to be, the vector is going to have 10 numbers in it. So you only use rand when you're filling out the for loop, but we can go back to that later. Okay, so we're going to set up a for loop. So for FOR parentheses, we're going to say int I equals 0. And then semicolon, I is less than, I'm pretty sure it's 10 if we're just going to have 10 numbers. Okay, and then semicolon, and then I plus plus. Yeah, there you go. And then outside of those parentheses, we're going to have brackets. No semicolon. So yeah, okay, perfect. And then enter, yeah. Okay, so vector list, your name of the vector. And then square brackets I, with I inside.
Square brackets.
Square brackets, yeah, perfect. And then letter I. And then get outside of the brackets. You can delete that space. It's just I inside brackets. Well, it doesn't really matter. So the I should be inside 2 square brackets.
Like, so like
Yeah,
this.
square. Yeah, there you go. Space, same line, equals sign. And then this is where we call our random number. So RAND parentheses. So they're empty parentheses, yeah, and then go outside. I don't think it matters how big the random number is. So that's pretty much all we need. All right, so semicolon, and then that should be the end of it.
We don't need to declare random over there.
What was that?
No, I'm sorry. We don't have to declare an int random, I guess. So it's useless.
Yeah, so we
Yeah.
can delete that. Okay.
And sorry, if I can ask a question, why did
Yeah.
why put less than 10 in this case for I in the int I equals 0, I less than?
Because that's how many, we have to set that up. We have to say that vector list is gonna have 10 entries.
Okay. So I just want to make sure.
Yeah, the
Forgot
professor
to
said
add
the vector going to be only 10 items inside.
Mhm.
So, would it be I less than 0, or would it be I less than or equal to 10?
Oh,
What
you're
would be
right.
the case?
All right, so we can do, I is less than or equal to 10. We can just do I is less than 11 if that makes it easier.
No, from 0 to 9, we need
0
that's
to
10.
9.
That's
Oh,
10 items.
okay, yeah.
So less than
I
10
forgot
should be
I forgot that the first entry is 0.
0. Yeah.
Okay. So 10 is okay, yeah.
The vector list start from 0. So
Mhm,
0
yeah,
to 9. Yeah.
you're right.
The Jaden.
Okay, so there we go. Before the for loop, do we have to say that vector list has 10 entries?
Is that an input?
Actually, you know what? We'll look back at it later. We'll just see if this works. Okay, Hasantha, we were gonna do a for loop to print everything out.
Okay. So
I feel like you can
it's
do it
kind
in
of
the same loop.
in this, yeah, same sort of.
Same loop. Yeah. Okay.
So you can put C out, vector list, I. You have to put the square brackets I. So each time it's gonna print the element number.
Like
Each time
that?
yeah, the vector list square brackets I. Then probably put like a new line and endel. Yeah. No, like
Ooh,
you were right. Just go ahead like
okay,
that
okay.
and endel. Yeah. You can try to run it and see. Should work. Include string. Include string actually. String.
Like
It should be string, string.
string. Oh, include
Yeah.
string.
Yeah, I'm sorry. I said no. The string should be string, not stream.
Oh, in here, like this should be a string.
No, the one on the
On
second
line
line.
2.
Second line.
The one on the second line. Right
Yeah, it should be string, not the stream. Yeah.
I think it's gonna be, okay, so, for vectors, I don't think we can do, vector I equals, so you have to use a push function. Or pushback.
How do you do that?
Oh, yeah.
Vector list dot push. Oh yeah.
Does that make sense what I'm trying to say, Hasantha? Or Kate, I guess. For vector, you can't, since the vector's empty, you can't just say a vector's 0 position equals a number. You have to use pushback.
Okay.
Yeah, vector list dot pushback.
I try to use the pushback, but it gives me error here.
So where does try to fix it?
Yeah. So instead of that square I bracket after vector, you can erase that part. Yeah, go backspace.
Like,
Yeah, keep going until the vector list. Yeah. End of the
so
vector. Yeah, one more. Then a dot pushback. Under yeah, there's a, I don't know what's the name for that.
yeah.
Michael, you can help here.
Oh yeah, underscore, push underscore back.
Back, yeah.
And then you can place the rand inside the parentheses. So left parentheses, yeah.
Like this.
Perfect. That should work. Cool.
good.
When we change the line 15, should we also change the line 17? The vector list I is still the same, or
It should be same. We have the C out there, 10 numbers. Because when we print out, we print in by 0, 1 each time the for loop iterate.
So I should copy this and put it here.
No.
No,
No.
I think that's right.
So when you have a vector, you can't just say the position of this vector is something. You have to push it in, meaning I don't know how to explain the pushback function, but so if you have an empty vector, you can't just say vector position number 10 equals a number because it's empty. So you have to use a pushback function, which pushes it to the end of the stack. So it pushes it. It doesn't matter what position. It just pushes it to whatever the vector is.
Yeah.
So if it's so right now there's nothing in it. So it just pushes a number in the last position, which would be 0 in this case. And then if you use it again, it'll push another number, say 5, into the second position, and so on and so forth until you get a vector. So then all you're doing for the C out is you're just saying, since we already have one integer in the vector, you're just calling that position 0. Now that position 0 exists. So vector position 0 printed out, which is whatever the random integer is. Oh, what's the next part? Oh, is that me? Sorry.
I think so, yeah. I don't remember what's the
Okay.
part.
Okay, are we doing the find the minimum or the maximum? I forgot.
Minimum.
Minimum,
Yeah, fine.
okay.
Yeah.
So for yeah, so we can say for size, so yeah, another for loop for size t, size underscore t,
T.
space, we'll use j, a t, yeah, you had it, yeah, j equals 0, comma, or not, sorry, not comma, semicolon, j less than vector list dot size. And parentheses, open close parentheses.
What's that? What's that?
Just
Oh,
the
go
same,
under.
yeah.
Or,
Oh, no, so the size is a function, so open close.
I
Yeah,
see.
thank you. Cool, yeah, perfect. And I think vector list, the L needs to be capitalized because it's yeah, perfect. And then semicolon j plus plus on the for loop.
Okay. J plus plus. Oh, one more. Okay.
Yeah.
Oh, semicolon.
Then and then curly brace. Let's see, so we want to compare each number. So I guess we can say, we can create a placeholder variable.
Yeah.
Yeah, sure. So before the for loop, let's just create a placeholder variable. Let's just call it int. Yeah, let's just call it int int min. Yeah, and then I think that's it, semicolon. Okay, and then now we can say min equals vectorless square brackets I or J, I guess, since we're using J in this case. And then semicolon. And then we say if, and then space, yeah, and then we're gonna have a if loop. If, wait, so it's gonna be equal to J. Yeah, we can say, okay, so we can say if parentheses, if min is less than vectorless J, perfect, and then, yep. Then do nothing, so leave it blank. So square brackets, or sorry, curly brace,
Sorry.
yeah, and curly brace. Perfect, and then go one down arrow. And then else. Curly brace again. Perfect. Min equals vectorless J. Okay, let me see if I did that right. So if the minimum, is equal to the first value, let's say 5. And if the first value is less than 5, then do nothing. If otherwise, so then the second value will go. Okay, I think we need 2 placeholders because it's just going to take the minimum of whatever next. Okay, let's actually put the minimum outside of the for loop. I think that makes more sense. So that, yeah, so that the min declaration, min equals vectorless. So line 25. Let's take that out of the for loop and put it on line 22. And for line 22, change the vector list to 0, from J to 0. Yeah. Perfect. Okay. Okay, so now the vector list is going to be the first number, and then if it's less than the first number, nothing happens, and if it otherwise it equals that number, and then the next number is 6. If 5 is less than 6, do nothing. Otherwise, it's equal to that. Okay, I think that makes sense unless someone sees a obvious bug that I'm missing. I guess I didn't even have to do the if else. I could have just done one if, but okay.
Yeah, I was just saying you can make it less confusing by just making it if minimum is greater than.
Yeah, that makes, that
and no
probably
else
makes more
statement.
sense.
I guess we could check if everything's formatted correctly to make sure everything's in the right place.
Yeah. Oh yeah, we can do Tim's suggestion, which is maybe just make it less confusing. Just say if min is greater, so line 26, if min greater than vector, let's do greater than or equals to, right? Equals to, and then inside the angled bracket or curly brace, then we can say min equals vectorless J. Perfect. And then we can delete the else. Yeah. Yeah. And then semicolon. Yeah, it looks good. I think. Oh, and then I guess we should return or print out the min afterwards. So yeah, see out the min.
Here.
Yeah, C out, and we can make it less confusing by saying minimum value in quotes or something, just to make it clear. So so before the min, so yeah, before the min, let's do some quotes. So quote, the min value is yep, perfect. And then double carrots. Yeah, perfect. Okay, we can try running it. Ooh, is that right?
It's sort of better we control that random number size, like put a percentage divided by something, so it always keep in that range without going
Oh yeah, that's true. Yeah, we can make it like within
like
20 or something.
yeah 21, so it always get under 20.
So for line 17, right after rand, we can do percentage sign 20. Yeah, so then that'll give us just values from 0 through 20 or 1 through 20.
19.
19.
0 to 19.
Thank you. Oh no, 20, but okay, let's try running it now. Less confusing. Oh, nice.
Yeah.
Clean. Right. What's the last thing to do? Oh, can we scroll up on the, can you make the terminal window a little bigger? On the very bottom, the input window? That, where, yeah,
Okay.
just to make sure that we got everything. Okay, cool. So it's, okay, great. Yep.
Nice.
Hey, I haven't learned vectorless yet. So what exactly what a vector is?
So it, so you can think of it as just a list that holds numbers. So an array, are you familiar with arrays?
Not yet.
So instead of having like a ton of variables, so let's say you have variable A equals 5, variable B equals
Yeah,
6.
like having a bunch of integers.
Yeah, instead of having a bunch of integers, you simply just have one vector, which is just a lot of integers, but it's just in one variable.
Yeah.
And it's just a list of those vectors, and you can
So
access, yeah,
you declare it by having vector, and then they are integers, and then you call it vector list.
exactly, yeah.
It can be anything actually, integer, strings, double. You have to name that thing over there in the characters.
Okay, but you never know like what's in the list, or do you know? Like, so I guess you declared here that it's up to only like 10, but otherwise you wouldn't know.
So when you're declaring it, it's empty. So on our line
Okay.
10, once you
Oh, okay.
declare it, it's completely empty. And then you want to start adding values using the pushback function, which we did in line 17.
Okay. So what's the whole point of this again? What was like the big question he asked?
I think the main purpose was to create a vector and then find the minimum value of that vector.
Then sorting it, I guess that's the main topic to sorting arrays.
Oh, cool.
I don't know whether we should do that part or he gonna.
Right. So what are these numbers? Do we have any prior knowledge about the existence of this? Like they just came out of nowhere, like the console just gave you a bunch of numbers and it just happened to be the minimum of like 2.
So our first for loop on line 15,
Yeah.
what we're doing, so we set up the for loop, it's from 0 to 10,
Yeah.
and vector list dot pushback. So we're saying that our vector list use the pushback function, which is just saying insert the value, insert a value, and the value we're inserting is random. And the %19 is just divides, or is the remainder of dividing by 19. So whatever your remainder is dividing by 19. So as when you saw earlier, it was like a million, right? It was like a million,
Yeah.
2 million or something.
Uh,
You're just dividing that by 19 and getting the remainder. So for example, if your random number was 20, %19 will give you 1, because 19 divided by 20, remainder 1.
yeah.
19. So essentially all you're doing is you're just adding, putting values in your vector. So the first iteration of the loop, when I equals 1, push a random value divided by 19 into the first position of in your list, which is number 2, as you see in the input window on the very
Uh-huh.
bottom. Second iteration of the loop, I equals 1, I is still less than 10. Push back another value, a random value divided by 19, which ends up being 15. And then the next iteration of the loop, I equals 3 or I equals 2, push 3 value, push the integer 3. So that's what you're seeing on that list at the input window that you highlighted. So every iteration of the loop, we're putting, first one we push 2, second one we push 15, third one we push 3, the fourth we
Yeah.
push 3, so on and so forth until
Yeah.
the for loop ends. And then the second portion of the for loop, we're saying that minimum.
Wait, can I try to like
Yeah, for sure.
understand it? So this is just to create a bunch of random numbers. It said for I guess there's our 10 outputs. You randomize each of them and then divide by 19 to get the integers, or not the integers, the remainders, and then you output them in the console or terminal, and then you create another variable to call it, and then here you sort them out basically just to find the smallest number. So here
Perfect.
is okay, if it's bigger than 0.
Yeah, so min equals vector list, line 22 is saying that my minimum value, I'm just gonna set it equal to whatever, something inside the vector list. In this case, we just chose 0 because it's convenient. Is the 0th position of vector list. So 2 in this case. So so vector list square bracket 0 means the 0 position, whatever's in the first position of your list.
So like first row.
Exactly, perfect.
Okay.
So it's saying that it's equal. It just happened to be the lowest out of
Yeah.
luck, but it could have been 15 or anything like that. But yeah, we just picked an arbitrary number. And then yeah, the second loop, like you explained, it's basically just taking this min value and comparing it to the next value. So it's saying min, is it bigger than the next value? Vector list 0, vector list 2, vector list 3. If it is bigger, then or equal to, then set the minimum equal to whatever that is.
Okay.
See, in line 23, since we are incrementing, we started from the 0. Otherwise, if we go other way, we could say the min equal vector 9 and decrease the j minus minus. So that way, so starting from the other end of the vector list to find the minimum.
Which line is that?
23, 22, like instead of declaring minimum to vector list, the initial item, we can say vector list equal 9. I mean, vector list 9. So now we're making the minimum to the last element, so which is
So
7.
like here, like
Yeah.
9, and then I can change it to minus minus. Is that
Yeah,
what you're
and
saying?
j should be starting from 10 or 9, I guess.
Okay, and then yeah, okay.
It should be incrementing. So it's, you're making the loop like flip around in a way, go from the other way.
Yeah. So these are just positioned in the list, right?
Elements, yeah.
Okay.
It's j starting from 0.
So you start from 10, and then minus means you just go back.
Backward, yeah.
Yeah.
So I think that the J should be greater than vector list size. Oh no, you're right. It will. No.
Yeah.
J should be greater than. I guess.
Wait, I'm kind of confused on that. Why should it be greater? Yeah.
Huh.
What?
It should work, huh? Even if you change the for loop. Size J start from 10. Each iteration J should get less. Okay, I think the J should be, it's not the vector list size. I'm sorry, Michael, that the middle part, it should be J less than or equal to 0, I believe, right?
Which line is it?
In the for loop, 23, line 23.
In here? What do you want
Yeah.
to fix?
So we start the J from 10. So each
Yeah.
time we have to go one below until the J hits 0. So
Yeah, so we have this.
Yeah, so the controlling condition should be J equals 0, I believe. The middle one.
The right here.
Yeah.
Do I put it in here?
No. Yeah, Michael, if you can.
Well, I mean, I think we should stay away from that convention because what you're doing. So if you can do it the way you're trying to say, but I think the reason why we don't want to is because that now you're hard coding values. So you know what your vector size is. So you're setting the J equals 10, right? Now you're basically hard coding it. You're saying, well, if you like, for example, if I added 5 more values to my vector list, now I have to change my J equals 10 to J equals 15. Basically you have to change 2 things in the code, right?
Yeah, no, I think his point was just to show me like others way it could be done. It could have been done.
Right, but I think it's
Yeah, we should stick with the original one, but yeah, I was
Yeah.
trying to show him without being the initial being this minimum.
Yeah.
Could be the last one.
Yeah.
yeah, I
Yeah.
agree. But it is it's just, yeah, it's not good practice. It just, I feel like it makes it more confusing than.
Yeah, it is. Yeah,
And,
it's normally easy to increment.
No, I mean like if you understand like the back and forth, I feel like you have better graphs of the material.
Yeah.
Thank you, Sahanta.
Yeah. No.
Thank you. Is that it?
So
Is it
yeah, should we-
usually like this?
should we try to sort this now with what we have?
Oh, sorting it.
Should we call the professor? What sorting mean? What you need, like sorting mean? Finding the minimum is sort of sorting also, I believe.
Yeah.
Mhm.
While we here, do you guys want to explain to me what is an array? Maybe Michael can help you out.
Yeah, that's an array is essentially a vector. Which is what we're using now. I'm not actually sure what the difference between an array and a vector is.
So a
An array
vector
has to
is a
be-
list.
Yeah, array has to be established up front, the size of it. You can't readjust the size of an array.
Oh, I see.
The
So the
vector,
vector
yeah,
has
with
the
the
pushback.
pushback, yeah, you can increase or decrease anytime.
But I didn't hear what Tim said. What he said.
Just saying that, like you said, the pushback is like a unique thing to vector. Arrays, you have to establish the the size of the array up front.
Oh,
And I
It can't,
believe
it
that
can't be adjusted once it's created.
so can it be random in an array or no?
I mean, the values can be anything you want. You can add,
you can,
remove, and change
Yeah,
them. But
yeah.
you
So
can't
do you
change
have
the
to
size.
declare it right away?
No, but
Okay.
the array itself has to be like the size. If it holds 10 values, it
Okay.
can
But
always
you just
only
have to
hold
like
10 values.
declare the value or the size first.
Yeah, exactly.
All right.
and one more thing, that array, no, vector is a static memory, so it doesn't copy itself. It is only use, as I remember, if it is correct. Array
So then you
copies.
should usually use array.
They say use vector. It's more controllable.
Oh.
But better to ask from the professor though.
I trust you guys.
Does anybody know how we would sort then these 10 numbers that we have by using the minimum, finding the minimum like we're doing?
Yeah, I was thinking about that. So I actually remembered something the professor said about putting a nested for loop. So if we put our second for loop into our first for loop, it might be easier. What actually, I don't know. Cause then as we're creating the array, or sorry, the vector, we can place the smallest one further back as we create it. But that might make it harder. Yeah, no, I don't know. Yeah, sorry, you were saying?
No, that's how it should be, I believe. Yeah. He said make a nested loop, and I think it's faster. It's kind of same if statement.
Yeah, the only problem I see is like if I guess we can just make a completely new for loop and just go through each value of the vector list.
Mhm.
Oh, okay. We can, so this is a very primitive way, but what we can do is just use our min. So we found our min, right? We just set it equal, we just swap the first and the last position. And then the next for loop will go just from 0 to 10. Then the next for loop, we go from 1 to 9, or from 1 to 10. Then the next iteration for we go from 2 to 10. So basically our position, yeah, we put them in the first position, swap the two. And then the next iteration of the for loop, we're only gonna look at the last 9 numbers. Then the next iteration, we only look at the last 8 numbers. Then the next iteration, we only look at the 7 numbers because, yeah. Does that make sense? What I'm trying to say? Okay, we can try that. Um, oh, that's like 3 loops. Okay. Let's create another for loop. I'll attempt this.
Yeah, he gave us an hour, I think.
Yeah,
So
Okay.
we want to do another for loop.
yeah, let's just do another for loop. We'll do the same loop, though size j is equal to 0, greater than, yeah.
So do we keep this or no?
Yeah, we'll keep it. We can just copy and paste it under it.
So like here.
Yeah, but do it after the min value, I would say. Just so we have yeah. Okay.
So when you type out a let's say, and this happens, do you use like the arrow keys to navigate, or like is there like a shortcut maybe?
I just use my arrow keys, but I don't know if anyone has any better like ergonomic options.
Yeah,
The arrow and the tab, basically. The tab gives you the
arrow and a tab.
tab, yeah.
All right, let's say, and then what the heck is that? Do I supposed to hold tap or?
No, no. Tab to get those like normal that I don't know what to say for that. Like, there's those gaps after the 4.
No, I mean like look, so like after I type ran, right? I open up a bracelet or what bracket, and then I use nav like the arrow key. Is there no way?
Yeah, that's the way I do it. I'm not sure if anyone else has other methods. I think let's copy and paste the same exact for loop inside again. The same exact for loop. No, for loop.
This one?
Yeah, let's do that again.
Where?
Yeah, right inside. Okay, let's change the first one to I so that it's not as confusing. Yeah, or we can change the second one to I. It's not the same. Well, it shouldn't be the same variable because then it'll be, yeah. Okay. Okay, so this for loop will find our minimum. Okay, so this for loop will find our minimum. So I think this one, copy and paste the if statement in the previous one and place in this one. So line 26 through 29, copy paste inside. Inside our second for loop.
Is this else or still if?
No, it's still if. And then at the end of that, so at the end of our for loop, so let's see, so many brackets, I'm confused. I think we're missing one curly brace.
Yeah, after 43. So line 38, if you can put a tab over there, it's gonna align right. Line 38,
Okay.
go to the start. No, left.
38.
Yeah, left side, one more. Then press tab. Then you should put a tab on 40 also.
Yeah, that's
Then
awesome.
42.
Yeah,
Then 43. 43, one more. Yeah.
and then make one
press.
more curly brace under it. Yeah, nice.
Yeah.
Perfect. Okay. So we found our minimum in the first in the if. So now for the first loop, we say min is equal to so hit enter and on line 43. Go to line 40. Sorry, go to line 43. 43 and then hit enter. Yeah. We can say so we say the vector list 0. Oh, sorry, not 0, j equals min. And semicolon. And then when we, so we found our first min, but then this is going to be a series of for loops. Actually, wait, so we found our first min and we placed in the first position. So now we want to find our second min, but we only want to go.
You can put a counter, I guess, and make the loop.
Counter. Can you explain?
Like after that min, the next line you can say we have to declare a counter in counter plus plus.
Oh. And then what do we do with that counter?
We can use that for the for loop. So each time the for loop goes there, start from.
Oh,
I guess,
yeah. Oh, that's good. Yeah, that's good. My only problem is we're making like 10 for loops. Does that make sense what I'm trying to say? Or am I thinking completely wrong? Because what I'm thinking next is, so we have our first min and we're putting in the position. So then the next, oh wait, no, sorry. I think, okay.
Yeah.
The next
one
iteration of the loop will be I. Oh, sorry. So line 39 and 41 should be I, not J. Or we just make it a counter, like you said. Instead of having it be I or J, we just have a counter, right? So,
It's a counter.
or just so a variable. So okay, let's go to line 34 and just say int, let's say counter. We'll call it a counter, and it's equals 0. So it's just gonna be a number that just kind of holds our position. So, or we can make it 10 and say 0. Oh yeah, let's make counter 10 actually. And then we can say counter minus I.
Yeah.
Or I'm counter minus I? 10 minus, no. We want
It'll be
no,
9.
it'll be 9, right? So we're only going from, we want to go from 1 to 10, right? Because our next iteration, we just want to go from 1 to 10. Because right now we're going to go from 0 to 9, which is not what we want. We want to go from not 1 to 10 or 1 to 9. So it would be, oh no, the for loop is gonna go 10 times though. And we're not gonna have 10 spaces in the vector.
So our initial for loop is counting up. Is that correct?
Mhm.
Could we use that, like that? I think it's J as the counter.
Oh, yeah. Yeah, that makes a lot more sense. Yeah. So J will start from 1. Yeah, that makes sense. But then we're gonna go too much. So our for loop is still gonna execute 10 times, which is too much. The second for loop on 37 will execute 10 times, but that's like gonna be bigger than our size. So can we say, oh, so we can say I less than vector size minus J? Does that work? So
Is it minus J or minus 1? If we're,
it starts at 0 and J starts at 0. And then once J iterates once, J is 1. I is gonna go from 0 minus 1. Oh wait, no, that's vector size minus J. So 10 minus 1. Yeah. So vector size minus J, right? Because the next iteration of the loop, J will be 1. Vector size is still 10. We minus 1. So now the I is gonna be less than, or sorry, greater than. Shouldn't that be less than? No.
It should be less than.
Oh, it should be less than. Oh,
Yeah.
that's a bug. So line 23, 25 should all be J less than. Right? Yeah, J less than. Yeah, so 35 is J less than vector size. And then same for 37, line 37, I should be less than vector size. Okay, I think that makes sense. And then put a parentheses for the left parentheses in front of vector list. Right
Where?
arrow. No, sorry. Same line we were at before. Yeah, left parentheses.
Left parenthesis, right? Like this, or
So yeah, perfect. And then move to the very end of the size. No, the size.
oh, right
So we're gonna have so minus J. And then, yeah, right parentheses to close it. Perfect. Yeah, that makes sense. Okay, so then now your I is only gonna iterate 9 times for the second one. Does that make sense? What's happening? Okay, and then so if vector list, so we only want to count, so we already set our 0 position to min. Now we want now we want to start at position 1. If we're starting at position 1, it should be yeah, if we're starting at position 1, how do we start at position 1? I plus J? Yeah. Okay, how do we start position 1?
What is position 1 supposed to be?
So we set our vector list 0 is equal to the minimum. So now we don't want to touch vector list 0. So we want to touch vector list from 1 to position 9. So we only want to iterate, so we want to iterate 9 times, and we want to iterate from 1 to 9. Vector list from 1 to 9.
So this is the middle for loop, I believe, right?
Yes. Should we just say I+1?
I plus plus. You can put I plus plus in the bottom. So always no. Yeah. So the size t I equal I plus one. That works.
+1. I think
Yeah.
it'll work, but
Yeah.
let me think about the second iteration though. The second iteration, you're gonna have the same problem.
That time the I gonna be one. So that's starting from two then. Right? But over there you have to initialize the I to 0 first. Then inside the for loop size t I equal I plus one. I mean.
Hmm. I think maybe we do implement the counter you were talking about. So we can just say
That
I
works. Yeah.
plus counter.
See,
Which line?
that is,
For so under vector list actually. So under 44, counter plus plus. And then we set counter equal to 0.
What?
Sorry, semicolon. Semicolon. So semicolon for that, and then go to line 34 and
counter
set the
0.
counter. Yeah, counter 0. So now the counter will. So now the first iteration counter will have 1, and since size t, so we want to start at 1. So we could say counter.
So
Right,
now,
just counter.
yeah, then line 37, the I should be equal to counter. So starting from 0, each time it goes 1, 2, 3. So
Okay.
37 size ti equal counter.
7 size ti equals counter. No, I no, because we wanted to because I is less than vector size minus j, which takes care of our looping issues or the amount of loops we want to make. So we're gonna keep I, well, at least my idea is that we keep I at 0, and then I is still less than our vector minus j, which is what we want. We want it to only iterate 9 times this time instead of 10. And then in our vector list, we're only going to look at the first value. So the counter is a bit of a problem. So maybe counter plus I then, because we're going to look at 1, 0 plus 1, then the next iteration 0 plus 2. That's what we want. Okay, so counter plus I in the vector list. So if min vector list, so sorry, in the line 39. Yeah, plus I. Plus I. And then same thing for the min equals.
No,
Oh
yeah,
wait, no. Yes, that makes sense. Yeah, plus I.
that works. Yeah,
Okay. I think that's it, right? Am I missing
should
anything?
work. Yeah.
Should we test run the code? See if it works?
Yes. I'm excited. Oh, we didn't print anything.
See,
Yeah, see out vector list. We'll print the whole vector. I think you have to make a for loop actually. I don't think it'll print out the whole vector, but we can try it.
it won't print out the whole loop because we are not saving it.
Do you want to say something in like quotation mark?
No, I just don't think it'll print out the list because, well, we can just try it. Let's just run it and see what happens. Okay, yeah. So we just need to make another for loop to print out the vector list.
How about we print out each time in the for loop?
Oh no, because we're gonna get a ton of random values because we're not it's not sorted yet. Right. So you're gonna get a
Okay.
ton of yeah.
Okay.
So we want to print out the finished sorted loop. So we can just say, so delete the 47 and just make a for loop. Same, I would say identical to line 35. Yeah. Yeah, and then see out vector vector list j. Yeah, and then end all. Okay, let's try that. Oh, oops,
So
no,
many twos.
nope, that's not it. Oh, all right, close enough.
So yeah, it's like take a step back and like talk like logically about what it's trying to do here, because we need to be able to like put those values somewhere that's not overriding existing values if we're gonna
I
create a
believe
sort of
so.
list, right?
So vector
Oh,
list
yeah.
j plus I should be, or the counter plus I.
It should be swapping the positions, not overriding the position.
Yeah, how do we do
Yeah,
that?
that makes sense. Okay, yeah, that makes sense.
Line 44, I think. Just give a sec. That has to iterate also, I believe.
Oh, okay. We have a second counter, and wherever that counter finds the minimum, then we swap the positions. Wait. Sorry, I just blurted out ideas. I'm just thinking out loud. You guys can.
I think the line 44, if we put j minus counter or something like that, so it get, and we should have a position to save the last element in a way.
Yeah.
So in the, if we find the minimum in the so the vector list j should be get pushed back or push forward and put the minimum behind it.
Sorry, if I can ask, why did we set if minimum to greater than equal to vector list?
So that is, we're saying that, so we give minimum an arbitrary value, right? So vector is position 0. We're saying that if it's bigger than it, so if min is bigger, so let's say min is 6, and the next vector on the list is 1. If min is bigger than that, that means the vector is smaller. So set the minimum equal to that new smaller number.
Oh,
So we can implement a counter here, I think, because every time this iterates. Or we can say else. Yeah, else counter plus, but I'm not sure. Yeah, essentially we're basically overriding each position as we go, which is not what we want. We just want to swap the elements in the array. Um, I mean, a barbaric way would just be just create a new vector and then just place everything in that vector.
I think that's not swapping though.
Sorry, say that again.
No, that's not swapping.
Oh,
I
it's
mean,
not
that's not. I mean, that's not sorting, I guess. Right?
Yeah,
Mhm.
yeah, it would. Yeah, it'd be barbaric.
See,
Okay, I have to go.
Yeah,
Okay. Yes. That was awesome though. I learned a lot.
where's
Yeah.
the professors here?
Alright,
I'd say,
bye
Classes
guys.
end like this usually.
Yeah, we got. Yeah, sometimes it doesn't, but I think we
Oh,
got
you're
Professor
muted,
Yun
Professor.
building. You
Yeah,
muted.
Michael, thank you. I heard you had to go.
Yes.
And I can see that you all had a great time. You know, I heard a lot of voices, Kate and Hasanta and Michael and Bao, all of you typing. Bao, was this useful?
Yeah, very useful.
Great, great. Okay, so I can see that this is not yet finished. It's actually supposed to be a very short program, which is, you know, this is great. Even if you took 100 lines, that's great. Try to get it completed. Organize a separate session. Same group of students, fine. Okay, maybe 1 hour max it'll take. For you guys, I think it'll take less than an hour probably to fix this. Organize a time. Anytime, does not have to be during working hours, right? After 7 p.m. even. Do a Zoom session. All of you guys coordinate via email or Reddit, okay? Get together, fix this and share this, and all of you will get extra credit for this, okay? If you fix this. It's a very simple sorting technique, and we can talk a little bit more about this before we talk about pointers and nodes next week. But certainly we can talk a bit more about this, but it's eminently within your ability to fix and share. So please do that. I will be able to help you, okay? Once you get to the next stage and you're irretrievably stuck, I will help you. Discuss it in Reddit, I will help you. I'll give you the fixed version of the code too. I'll take a look at it, fix it. It looks like it's a very simple bug, simple things. And also condensing the code will help you. So totally, I'm so jazzed up to see so much progress and so much excitement amongst you guys today. So please continue with this, and I'm going to look at this video more and look forward to your discussions. And also, if you do a Zoom session amongst you guys separately, take a recording of that and share that video with me, please, and I will publish that also on our channel if you want, right? If you guys want to have a private session, that's okay too, but I would prefer if you have a session and you record it just like this. This was fantastic. Okay, this is going to be so inspirational to future students, right? Several quarters down. But I'm only planning to teach for a little while longer now at Foothill, but certainly the channel will be there, and I'm pretty sure lots of students will find it useful later on, just to look at how students are working on this thing. Okay, and it's so valuable. Thank you all. Okay, and I gather this was a useful class. Was this a useful class?
Yeah.
Thank you. We'll try to have more of
And-
this. Hey, Jaden, yeah, go ahead.
Oh no, I was gonna ask about if he knows how to share this code to the Reddit.
Yeah, I just
Okay.
copy and paste it onto Reddit, right?
No, don't copy and paste it, okay? Click on the orange button. Okay, so that's the link, share code. That's the share code. That's the link you need to share on Reddit. And also, you know, say this is the code, and also say a few words about the code, okay? Say what you were trying to do and all, so that people who can click on it can basically, you know, follow the code starting from the word go. Yeah, just say a few words, one paragraph or a couple of sentences, and then paste the link in Reddit. Yeah, Bao?
Yeah.
Okay, and the rest of you should somehow before Tuesday organize a group, a study group or a Zoom group to work through and solve this problem. Get it working, okay? And I will look forward to that. And if you do that, I will, you know, you will all see a benefit in your grades if that's important to you, right? So fantastic. Thank you all so much. I had great fun just watching you guys. Thank you. See you next
Thank you
week.
all.
Have a good weekend.
Yeah, thank you.
Bye.
Yeah.
All right.